the schematic of an easy to make IF filter that can be used with coils. IF coils between, say, 400 kHz and 700 kHz. So also 455 kHz. That's a very common IF frequency. Here the used transistors. BF199, BF245, that's a field effect transistor, and BC159B or the BC557. That's the transistor here in the final stage of that IF filter. Here is the diode detector. I use an old school germanium diode, but I'm almost sure that you can also use a 1N90. That's also a germanium diode, common available. OA79 and OA81 are more or less obsolete, very obsolete, but you need a germanium diode. That's important for the radio detection. Here the second IF filter. There is a capacitor built in. Here we have exactly the same IF filter, capacitor built in, and I also want to show the test. Here is the circuit in real, and when you have such a IF amplifier, it's a good idea to buy 2 or 3 extra IF filters. You can often find them on flea markets, radio flea markets, and the third filter is in this case connected to the test oscillator that I've showed earlier. And the test oscillator strays out now the frequency of this IF filter. So in fact it's now very close to the IF amplifier here, and enough energy, even with loose wires here, is strayed out to detect on the scope the output of the IF filter and the frequency. It's 650 kHz. I took these IF filters, but I think afterwards that it were not real IF filters, but filters for, say, long wave radio. Don't know that exactly. I have to do somewhat more study, but I'm going to use them in the first experiments. Try to bring the frequency down here by soldering extra capacitors here on the frequency dependent winding. No problem. I have tested this circuit in the past also with IF filters of 455 kHz, so I'm sure that it works. Absolutely sure. I tune in now to see what happens when you have to tune these filters in that IF amplifier in a definite way, because now these filters are not in an experimental setup, but now we have here a real input and output impedance, and that means that the core must be tuned to that specific situation. A filter is never hanging in the air, and also in a test situation you can pre-tune your IF filters first. That was in the preceding video, but in the real situation you have to tune them again. Here is also a situation with a say input and output impedance. Anyway, no problem. So I tune now the second filter here. Let's see what happens. So now you can tune it in a definite way, and that's very precise. And it's now straying here. The cables are straying enough so that the IF filter picks up the straight out signal. But of course you can also connect that test oscillator to the mixer transistor, and I do that now here. That's also a way to do it, and then you can also tune that filter. Done that now. Tune again, and of course there is no difference. That's completely logical because we test it on the resonance frequency. And other locations to hook up the test oscillator is here. You can do that via a very small capacitor of say 47 picofarad. Also a good location. And well, that are the best positions to hook up a help oscillator. So I move now that help oscillator away from my radio. I now touch that oscillator output with my finger, and now my body starts to act as an antenna. So that in fact it doesn't matter much. This is the way to do it, and I hope this was a little bit helpful. And here of course the whole circuit again. For the real radio purists, it could be an idea to completely build this filter inside a tin plate box. And then after that make a hole in that box for the input here and the output out of the diode detector. That's also an idea. I'm gonna mount the VFO completely, or not totally, in a tin plate box, and I found in practice that in that case it could be not necessary to also mount the IF filter in a tin plate box. By the way, this is the mixer transistor. Here is the input from the high frequency stage. That is a field effect transistor. And here goes the VFO in via a capacitor that has to be tested out experimentally somewhere between say 10 picofarad and say 100 picofarad, even 200. That depends on the strength of the VFO signal. And you can here send in the beat frequency oscillator signal. It could also be here or here. That are things that must be tested out in practice. Also, of course, always via a small capacitor between say 10 picofarad and 50 picofarad.